Hello and welcome everyone to today's webinar. I hope you are having a nice weekend, and thank you for taking time out to join us today. And today, I am Hassan Stawadi, by the way. I will be the host. I'm happy to be the host of this virtual meeting. And today we are excited to have with us Uqayya bin Safi. Hello, Uqayya. Thank you for accepting our invitation.
Hello, everyone.
So Uqayya is a Google developer expert, and also she is one of the ambassadors of Women Tech Makers, as well as an ambassador of Women in Data Science at Stanford University. Uqayya is also a mentor at Google Startups Accelerator of Middle East and North Africa. And yeah, finally, Uqayya is a public speaker and a machine learning trainer. And in this evening, today, Uqayya is going to talk about how we can build a text classification model for the Arabic language. And yeah, we are very excited to listen to this talk. But yeah, so okay, I didn't move the slides.
Okay.
So yeah, as we said, our guest speaker is Uqayya. But before we jump into the talk, let me give you a brief introduction about our community. So what is Byte Jidda? So well, basically a community that helps people who are interested in data science, AI, scientific computing, data visualization, and we help them to use and understand the various open source tools, whether it is written in Python or Julia or even R. And we have a PyData chapter. So there are many PyData chapters around the globe, and we are one of them. And here's our team. So we have here Yasamin, Afnan, and Chada. Hi, Chada. Chada will be the moderator of today's meeting. So if you have any questions, please leave it in the chat or in the Q&A session box. We'll try to answer as many questions as possible. And yeah, I'm Hassan and Abdullah. So yeah, and we didn't forget to thank our sponsors. So thank you, NonFocus and Mozon, for supporting us. And yeah, finally, if you want to learn more about our upcoming meetups and talks, you can follow us on Twitter or visit our website bydatajidda.com. And I think this is pretty much it. I think you can take it from here, Uqayya. Thank you very much. The floor is yours.
Thank you, Hussein, for introducing me with amazing words. Thank you for all organizers in DataPy for inviting me in this session. I am so glad to be there, especially in March, which the month of women. So I hope to enjoy with this session. Thank you for all attendees and have a nice day. Okay, let me share my screen. Okay, today I'm so glad and so excited to talking about text classification. So that our title, how to build your own text classification model for Arabic language. This is Ruqayya bin Safi, as Hussein introduced me, Google developer expert in machine learning, and this is my handle in Twitter. I will be pleasure and happy if you contact with me, ping me for any question on Twitter. So our agenda today will give you brief introduction about the characteristic of Arabic language. Then we'll move to text classification steps, and finally will we take 3 examples in one notebook for hands-on. What is the characteristics or the main features or the special features of Arabic language? Arabic language is one of most widely spoken in the world. It is the oldest, one of the oldest language in the world. The Arabic language has many features like the direction. It's written from right to left, no lowercase, no upper cases for the letter. The shape of some letters can be changed according the position of this letter in the word. For example, in the first or in the beginner of the word, alba, like this, in the middle and in the last, in every position, right in different way. The last point, which rich morphology, which that's make Arabic language tricky for most or of anyone try to enter natural language processing, because it's rich morphology, complex syntax, and difficult semantic. Okay, so if you want to applying text classification, there are many steps, maybe 6 or 7. If we add gathering and deploying the middle, will be 7 steps, but generally there are 5. What's the 5 steps? The 5 steps, if we ignore gathering and preparing the corpus, first step, document pre-processing, document representation, dimension reduction, build and training model, testing and evaluation the model. Let us go to the first step, which document pre-processing. In this step, what happening? In this step, we remove samples like emoji, numbers, stop words, links, URL, applying some process like stemming and lemmatization, and so on. So now we have clean text. What's the next step? Or clean crops. The next step, document representation. What we mean document representation? So the computer didn't understand the string or the text. We need to recognize the text. So in this step, we represent the document from the format which takes to good or number format which the computer can understand it. So the document have to be represented in the format that classification algorithm can recognize. There are many methods for document representation. For example, a bag of words, term frequency, and inverse document frequency, TF, ITF, latent semantic indexing, n-gram modeling, word embedding, word, for example, word to vector or graph or some advanced methods. Okay. Let us take the first example, brief introduction about the first example of document representation, bag of words. Everyone go to natural language processing, I think use the bag of words like hello world in natural language processing. So what is the bag of words? It is like simplest way to present text in number. Like this figure, we have, we present every first step before we represent. We take feature, or select features from words and represent these features or words as the header or of matrix. So this is the first sentiment or review in this example, and in this review or sentiment, uh, 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 the first word this exists. So but one a movie exists. So but one and so on, not exists in the review number one. So but zero and so on. This is the matrix. So this represent the frequency of the each word in this document. The second example for represent a document which is term frequency and first document frequency. What's that mean? It is a method or way to assign weights for every words in the document based on the frequency of this word in this term, in this document, based on all document. This is the formula which we use to calculate this weights, or this it is like give every word the weights which reflects the importance of this word in the document. Word embedding. What's this? That mean this is also method for enhancing natural language processing, which depend on what, on the semantic and syntax relation between word vectors. So in this picture, we have a relation between queen and king, and woman and man. And how can recognize this relation when present the word as vector? So when the vector is very close from each other, we inverse there are relation between them. Dimension reduction. The computer have limited power. So if we have 100 or billion of words or huge data set, so how the limitation of computer can process this text? So we need to some way, some method to select the important features, and these features be input for the classification model. So select the most representative features as input for the classification step. Why? Because the limitation of power of computers or processing. Fourth step, building and training model. So this is the main step in every model. Building the architecture of model, then training the model. We choose actually we split the data set to training and testing. We chose the training set to establish training and performing learning on it. After that, generate model. This model go to the next step to testing and evaluation. How we perform this step by pass the training set to the model and calculate the result, the evaluation based the accuracy or the compile. In the compile, we put optimizer and loss and accuracy that related our or fit this model. So we calculate the evaluation score. Then we decide what we will happen, or they decide our decision. So either retraining the model, or this model is ready for deploying and using, or register model. So this is the last step, which after that decide or take our decision if go to production or still retraining. This is our hands-on example of let us go to this because it's calculate. It's just stop sharing. Okay. Oh, I need. So I need because if I train the model, is take a lot of time. So I want the notebook with the output. So it exists there. So let us go through the hands-on model. We have 3 examples. Each example we use different technique. First example using TF and IDF. So the first step in any classification or any step in any model, import the library that we need to our training. Then prepare the data, or gathering the data, or if exists, just loading the data. We have already data which contain 58,000 baumets, which extend from the 6th century to represent today, which is are scrapped from this website, adapt the output or the problem or the target of this notebook. We need a model that can predict about this names for each pound. Okay, so we load the data from Kaggle. First step, pip install Kaggle. Then my API authentication, it's hidden there, but I bought my token for Kaggle to download the data and hidden it. After that, the link, this is command which contains the link for download the data, unzip, let me unzip the data from competition which launched in February, which is called ML Olympiad. So I want to use the same data. Unzip the training and when use Panda to read, we have this article, this what's this columns, poem ID, the link, style, فصحى or عامي أتوقع. Yeah. Poem text, the title of the poem, the category, and the about ID, and so on. Next step, this is the basic step, which load the data. The first step, document pre-processing. So we need to clean this text. This is what we say there. We remove emojis, symbols, stop words, UR, and so on. So this is emojis, punctuation is clean emojis, symbols, flags, also numbers, remove numbers, special characterize or letters, underscore, URL, users. If we have always, if you have in Twitter, the users, remove them. Then apply this method for clean text in the data frame of poem text, which is this. Just we need this column. So, okay, spell data, yeah, okay. Clean the text. So now we have just one data frame, one column and data frame which is ready after cleaning. So we have the training or the column for training, and we need the label which is the name of pout. Print the shape. Now we need to go to document representation, and as well as dimension reduction, which is the second step and the third step. First step to represent or subtask of represent the document, factorize the training test. How can I factorize? We have many methods or ways. I choose tokenizer class from TensorFlow for apply representation as well as dimension reduction. This class for factorizing the text corpus and have one argument called number of words. Number of words, I pass it 100, so it is kept and in memory just 100 of words. So next step fit. So in this step we take an instance from the class called tokenizer. Where is this tokenizer? Tokenizer exists in TensorFlow keras pre-processing text. So this is an instance. We need this instance to recognize our text or updated by our text, which is text, which the poem, this column. So we pass the text on method called fit on text. So now this tokenizer updated by our text. Next step, we need to transfer or convert this tokenizer to matrix. So we use a method called text to matrix, pass our argument text as the first parameter and choose the model TF and ITF. So when print text training, I don't like to click on run cell because it take a lot of much of time. Maybe the time of session not enough for training. Okay. Now the tokenizer, the training set ready and represent as matrix or vectors or numbers. We need also to factorize the labels or encode the labels. We called label encoder, create an instance from label encoder, which exists in not class tensor scikit-learning, exists in scikit-learning. So we will use for factorize or encode the label. So in encoder, label encoder, there exists a method called fit transform. We pass our label, which is the name of Paul, the column of names of Paul. We need to define the number of classes. So we use number of unique and print. When print, we print or print 652. We need also method to put every label in categorical present using two categorical. So now our data is ready by applying document representation and document reduction. Now we need to split just for evaluation in the training, but in testing we have already data set. We didn't use this data. It's built for testing. We have already testing data set in other link. So just for evaluation and for training. Now we split our data. Then we build our model, the architecture of our model. So sorry, I have just a problem in the mind. Okay, we built our architecture of model. We use a sequential model with exit in Keras. Take an instance from this class sequential. Then we add a dance layer. We define our input shape. The input shape should or have been the same number of tokenizer. Also 100. We pass the same variable. Add activation layer, relu, and then drop out layer for overfitting, reduce the overfitting, which maybe occur in the training. Add also a dance layer, but here it's the output layer. So this is the input layer, and we have drop out this just 2 layers. No. This is two layers. Maybe I have to add the more layers. Okay, this is a dance layer, number of classes. So this is the output of layers, which have be as same as classes or number of Paulet in our data set, and add the activation activation method, which is sigmoid. Sigmoid mean either 0 or 1. Then we need compile. What's the compile doing in the training? It is for optimizer the training. So it's calculate the loss and accuracy and try to optimize the process of training based on the loss and the matrix. Now we build the architecture of training. Now we want to fit our model. Fit what's the training data set? Training data set which fit to the model. It's called X after spelled the training. The data set spelled, so the training called X, and the labeling Y. Validation dataset which X file and Y file, and the patch size, the number of or the patch of which pick from dataset to fit to the model an epoch, the number of iteration. So I defined or 10 epochs, 10 iteration of training. So finish training, move to the next step, which testing and evaluation. As I mentioned before, testing dataset exists in this link because the dataset or I fetched the dataset from competition, so it does not exist with label in this link. So I upload it in GitHub or with the labeling, and now fetch it or try to download it from this link. Now we try and convert it to data frame, read by Panda, and convert this data set to data frame, print. It is same columns. Now apply the same steps which for pre-processing the data, label encoder for encode the labels. What happened? Reconnect. Yeah. Okay. Apply clean text, the method of clean text in the column of Paulin text. Also, trans or convert or using tokenizer. That's same step, but here for the test data set. Now we have ready convert from format like string for to format which can fit to the model. Now evaluate the model and print the score as you see there. We can also, this is a score, but we want to see the prediction as string. So how can see the name of about this as a string? We use we fit the data set and the same tokenizer to prepare a token. So a token is ready. We use model predict with the argument of token. Then we take the high argument or max argument prediction, use encoder method which exists in encoder or called inverse transform to return our result from numbers to string. Inverse the process, and there the name of prediction just print and all the names that our model predicted. Okay. We have another example. We use in this model in the previous model TF, ITF, and now we want to use another example for the same data set. So we will use text factorization. In the previous example, we used tokenizer. Now we want to use something new, which is called text factorization. Okay, so we initialize our what's a variable for passing and text factorization. Before go through the model, I want to explain what is the text factorization. It is a layer exists in TensorFlow dot keras dot text dot layers has same features that exist in the class tokenizer, but it is like layer. We can pass it in the model. Okay, so it's take many argument, max of token. So not all the words we can talk. The output we can define what's the output. We can use int, we can use count, we can use TF, trim frequency, inverse decrement frequency. If you go to the documentation, you can see it. The output also, I can just, yeah, the output sequence length I define, or I choose 100. So now this is just initialize instance from the text factorization. We want to adapt or update this instance by our text. So we use the method which is called adapt and fit or pass our text. So now the text factorize recognize our text. Now apply this text factorize and also our text. So in X2 train, we have a tensor which has a shape like as you see, the same shape of our data frame. Now build the architecture of model, which is different on the previous example. Also, we choose sequential, but now we add embedded layer, which is enhancement to recognize the relation between words, pass the argument, number of words, which will be 500, the dimension 100. I choose the input length, which the same training shape or the same column, because the shape of training, stop there, the first in the shape, the first or the shape 0, 57, 812, and the shape number 1 will be, or as you see, 100. So like 100 there, that's mean 100. Drop out for overfitting, and also we add the second layer which or the third layer, which is LSTM. It's a strong algorithm for a sequential model. We pass a number of unit 100, also drop out for overfitting, and the last layer for it's the output layer, number of classes, and the activation. I choose segment. Last step or compile, which is for enhancement or optimize the model, calculate the loss and the matrix, then the optimizer during the training process update the training model with the update the model based on loss and accuracy. Print the summary just for calculate the parameter and take big picture about the architecture of our model. Now our model ready for training. We fit the training dataset and the label, validation, and training. Start training the model. The result, evaluate the result, print the score, and that's it. Okay. Like the previous example, we can see the result, the prediction result as a string by the same steps which we use for pre-processing the data. In the previous example, we use tokenizer to prepare our talking. Now we use text factorizer, which is the instance of text factorization layer. So we for prediction we have to use the same method which we use it for pre-processing. So this is the result. Last result, we didn't create we didn't create or build model. We use a model, pre-training model. One of the famous a lab called Camel Lab. So I pick or I choose pre-training model which exists in Hugging Face. This is the link. We can try the model, pre-training model. For example, this is the line. Click compute. We can use this model, pre-training model, for transfer learning or fine-tune our model. I take it as it is. I don't change anything, just use. But everyone can use this model as pre-training model and transfer learning based in this model, because this model uses the same data, but there the prediction, not the name of Paul, just the name of or the like in Arabic al-Bahr. البحور الشعرية. So the prediction, the label is البسيط or الوافر البحور الشعرية. So just for the using any pre-training model as it is, just we need to install the transforms, import the library. We need pipeline, and the pipeline we choose text classification and the model. This is the model, and now fit or pass our text, which is the first line from data set. This is the line, and print the result as you see البسيط, which mean بحر البسيط في البحور الشعرية. That's all. Any question? Any comment?
Thank you, Ruqayya, for your time and your valuable information. We have questions from BT. Can you share the link of the notebook with us?
Okay. Okay, because can I want to, yeah. Stop sharing because okay,
Yes,
just okay,
stop.
okay, okay. Okay, this is the link. Oops, just for everyone. I have to choose for everyone. Yeah. Any another question or comment? I can't help but noting the accuracy low. Yeah, for prediction. What is the model can you to enhance the result? Yeah, that is a good notic. The accuracy is really low. We can hypertune the parameter, or when use the transformers. I think we will get big or high accuracy in general. Natural language processing in Arabic, especially in Arabic, it is tricky. We can't get the high accuracy with the normal algorithm like or the basic algorithm. But if we try to hypertune the parameters, we can get high accuracy. Any question?
Yes, I have another question. Thank you very much for this interesting talk. My question is, Yani, I think the pre-trained model that you showed from Camel Lab, as you said, is doing another task, which is,
yeah,
I think, predicting البحر الشعري.
Yeah.
Is it easier than the task that يعني, you were trying to accomplish, which is, I think, predicting the name of the poet?
Yeah, I think for transfer learning or fine tune, I think it's based on a pair transformers. So transfer the learning from this special this model will be easier, and we can get a high score, I think. Model
Yes.
is for prediction. Thank you, Meter. I don't know what's the translate of البحور الشعرية. I think called Meter. Yeah.
Yeah, I have another question if you don't mind. I didn't notice which one of the methods that used have performed better. So I think you used dense feed-forward neural network and also STM, and then the last one was the pre-trained model from Camel. Which one of these methods performed better?
You mean this in the second example? You ask me in the second example?
Yeah.
Or, yeah. In the second example, we use text vectorization layer just for representing the document, then embedding layers for the relationship or vectorize represent transfer from the integer that exists in text vectorization to vectors. So vectors detect the words that what every words close from each other. So then LSTM, which for sequential model, it's also get or for something like how I explain. For high accuracy, also embedded at LSTM, then dense layer for classification. Just that's you mean?
Yeah, it's okay. Thank you. Do you have any other questions, or we can conclude our talk today? Okay, I think that's it. Thank you so much, Ruqayya, for this amazing talk, and the hands-on session was amazing. يعطيك العافية. We hope to see you soon in one of our upcoming meetings, inshallah. Thank you very much, Ruqayya.
Thank you for you, Hussein, for Shada, for also for everyone. Everyone attend and all the team without mentioning any names. See you, inshallah, in next session is. And thank you for inviting me.
Our pleasure, Ruqayya. Thank you very much. And thank you all, for attending this meetup. If you want to learn more about our upcoming meetups and talks, as we said, follow us on Twitter or visit our website. Thank you all, and have a nice, good night of